Good morning and welcome to Thursday's Maths, where we are going to have a little look at multiplying fractions and then we're going to have a look at dividing fractions, and we're going to look at the relationship between the two things. So with division and multiplication, hopefully you know that these are the inverse of each other, the opposite of each other. So if we did 10 divided by 2, the answer would be 5. If we did 10 divided by 5, the answer would be 2. But we could also say 2 times 5 is 10, or the other way around, 5 times 2 is also 10, because these three numbers are linked together by multiplication facts and division facts. So now we can start looking at that, using that relationship with fractions. So 4 times a half is actually the same as saying 4 divided by 2, because as we already know, the times sign with fractions can mean of, so you're asking for half of 4. Half of 4 is 2. 4 divided by 2 is 2. So dividing by 2 is the same as timesing by a half. At first this might seem a little bit confusing. Timesing by a half is the same as dividing by 2. But think about it in the real world. If I said to you, I want to find half of this whiteboard. I want to times this by a half. I want to find half of this whiteboard. I would cut it into 2 equal parts. I would cut it into 2. I would divide it into 2, because timesing by a half is the same as dividing by 2. It's the same as you're still finding a half. Dividing by 2 finds a half, and that's what this is asking you to do. If I wanted to find a quarter of my whiteboard, I wanted to find a quarter of it, so a quarter of, remember, means timesing by a quarter because this times sign means of. So if I want to find a quarter of this whiteboard, I would have to divide it by 4. I'd have to split it into 4 parts. What about then if I wanted to find an eighth? I wanted to find an eighth of this whiteboard. Well, hopefully you would tell me that I would need to split it into 8. I would need to divide by 8. Let's see if we can start trying to see a pattern with these numbers. So 6 times 1/3. Well, a third of 6 is 2. So timesing by a third is the same as dividing by 3. So hopefully you can see that if you're timesing by a half, it's the same as dividing by 2. If you are timesing by a third, it's the same as dividing by 3. If you are timesing by a quarter, you are dividing by 4. And if you are timesing by a fifth, you are dividing by 5. Now, if that's still a little bit confusing, don't worry, because hopefully as we go through this lesson, you'll start to understand why that works. Okay, for our first question, we're going to do 8 wholes times a quarter. Now, to look at this at first, you might think, I don't know how to work this out. Well, there's loads of different ways you can do this, okay? And we're going to talk through a few different ones, but once you get the hang of it, this is actually really, really easy. So, if I said to you, what's 8 times 1 banana? You would hopefully tell me it was 8 bananas. What's 8 times 1 chair? Well, it's 8 chairs. This time, rather than being in chairs or bananas, my noun is quarters. So what's 8 times 1 quarter? Well, the answer would be 8 quarters. Just like it was 8 bananas or 8 chairs, it's 8 quarters. If I've got a 1 quarter and I'm timesing it by 8, well, there's another one. There's 3, there's 4, there's 5, there's 6, there's 7, and there's 8. Ignore the not fantastic diagram. But hopefully you can see that 8 times a quarter would be 8 quarters, which we could also turn into, well, if 1 whole is 4 quarters, 2 wholes would be 8 quarters. So you could actually write this improper fraction as 2 wholes. Another way we could work this out is by saying that we know that 8 wholes is the same as 8 over 1. We don't write it like that because it takes a long, long time, but we could write every whole number as over 1 because they're split into one piece. So 8 wholes is the same as 8 over 1. If I then write it out, I'll write it again so it's a little bit neater for us. What we can do is we can then do exactly what we do for normal multiplication. So we can multiply the top, the numerators, so 8 times 1 is 8. Then we can multiply the denominators, 1 times 4 is 4. Hopefully you notice we've got exactly the same answer as before because you're just timesing the denominator by 1, so it's not going to change, which we know is the same as 2 whole. A third way we could work this out is by thinking about what we were doing earlier. If timesing by a quarter, times can mean of, so we're asking for a quarter of 8. A quarter of 8. So trying to find a quarter of the something is the same as dividing by 4. So 8 divided by 4 equals 2. And again, we've got the same answer. So we've worked out our answer. We've proved it 3 different ways. Okay, for our second question, we've got 6 times 1/3. So this one, you can say, well, I'm going to pretend that this is, well, I'm going to make this the noun. I'm going to say it's apples. So 6 times 1 apple would be 6 apples. So, but it's thirds, so it would be 6 thirds. I can prove that by saying that I know that 6 wholes is the same as 6 over 1. Then I would multiply it across exactly as I would with multiplying 2 fractions. 6 times 1 is 6. 1 times 3 is 3. How can I turn those into a mixed number or a number? Well, 6 over 3. 1 whole is 3 thirds, so 2 wholes is 6 thirds. So this also equals 2. I could also look at this, however, if I'm timesing by a third, it's the same as dividing by 3. If I wanted a third of something, I divide by 3. And 6 divided by 3 is 2. Now we're going to look at some different questions, and I want you to start thinking about what's the best method for you to use, because sometimes you won't be able to use all of the different methods. So, 4 times 2 thirds. Well, I can think about this as the noun. So if I've got 4 times 2 chairs, I'd have 4 times 2, which is 8. I'd have 8 chairs. If I've got thirds as my noun, I would have 8 thirds. I then need to turn this improper fraction into a mixed number. Well, 3, 6, 9. I don't have enough for 3 wholes, but I have got enough for 2 wholes, which would be 6 thirds. But I've got 8, so I'd have 2 thirds left over. Right. I could also say that 4 is the same as 4 over 1. And this seems to help people make a number times a fraction just like multiplying 2 fractions, which seems to make sense for more people, for some people, and that's absolutely fine. You're doing exactly the same thing, but it's just making sure that you're not timesing the whole number by the denominator, which some people sometimes do make that mistake. So then I times it exactly how I would a normal fraction. So 4 times 2 is 8. 1 times 3 is 3. Oh, it's exactly the same answer. So it's 2 wholes and 2 thirds. Now, for this one, you're going to struggle to do 4 if it's timesing by 2 thirds. That means I need to divide it by 3 and then times it by 2. This is going to be a little bit tricky to do this as a division fact, to do the inverse, because 4 divided by 3 is going to leave you with a fraction and not a whole number. So for this question, because 3 is not a factor of the number, I wouldn't try and use the division method for this one. Okay, have a go at these questions and then we will go through the answers. So for the first one, 25 times 1/5. I know that I can do timesing a fifth, finding a fifth of something is the same as dividing by 5. 25 divided by 5 is 5. Or you could have done 25 times 1/5 would be 25 fifths, which would simplify, which would convert to 5 wholes anyway. Next one, timesing by a third is the same as dividing by 3. I can do 6 divided by 3, which would be 2. Or I could have done 6 times 1/3 would have been 6 thirds. 1 whole would be 3 thirds, so 2 wholes would be 6 thirds. So proving my answer. Right, for this next one then, I'm multiplying the fractions. So I multiply the numerators. 1 times 2 is 2. Multiply the denominators. 5 times 3 is 15. Can I simplify that number? No, because they don't have a common factor, because 2 is even and only has the factors of 2 and 1. And 15 is odd, and there's no point dividing by 1 because it wouldn't change the number. Right, next one, we've got 1/6 times 2/5. So I'm going to multiply the numerators. 1 times 2 is 2. 6 times 5 is 30. Right, can I simplify this number? Yes, because they are both even, so I can divide them both by 2. 2 divided by 2 is 1. 30 divided by 2 is 15. So hopefully we're pretty confident with multiplying a fraction by a fraction or a fraction by a whole number. But what about if we got a mixed number times a number? So for this one, the best way to do is partition your mixed number. So split it into your 1 whole and your 1/3. Because 1 whole and 1/3 times 3 means 1 times 3 and a third times 3. 1 times 3 is 3. A third times 3, this is what we were practicing earlier. So 3 lots of 1/3 would be 3/3. Hopefully you all can tell me that 3/3, 3 out of 3 is the same as 1 whole. Now you need to add these two numbers together. So 3 wholes add 1 whole is 4 wholes. Okay, pause the video and have a go at these. Remember, partition the mixed number. So, for the first one, 2/4 times 3. I'm going to split this into 2 wholes times 3 and 1/4 times 3. 2 times 3 is 6. 1/4 times 3 is 3/4. So my answer is going to be 6 wholes and 3/4. For the next one, I've split 3 wholes and 1/5 times by 2 into 3 wholes times 2 and 1/5 times 2. 3 times 2 is 6 wholes. 1/5 times 2 is 2/5. So my answer is 6 wholes and 2/5. Now it's time to look at dividing fraction. Now, a lot of people look at dividing fractions and think, I don't know where to start. But it's a lot easier than you think. This is a quick, easy trick for you to spot. Now, you won't always be able to work out a division question like this, and I'll teach you a method that always works in a moment. But sometimes this might help you get an answer really, really quickly. So if I said to you, and this is similar to the noun method we were looking at earlier with multiplication, if I said you've got 2 chairs divided by 2 people, they would get 1 chair each. If you had 2 bananas shared between 2 people, they would get 1 banana each. So if you had 2/3 divided by 2 people, they would get 1/3 each. I'll try and draw a third. There's 1/3. Ooh. There's another third. Obviously, they should be equal. If I divide them by 2, you would get 1 each. You would get 1/3. So this method only works if you can divide the numerator by the whole number you are dividing by. So for example, if I had 6/9 divided by 3, well, if I had 6 chairs divided by 3 people, I would have 2 chairs each. So 6/9 divided by 3 is 2/9 because you can do 6 divided by 3. However, if this question was 7/9 divided by 3, you can't do 7 divided by 3, so you couldn't use this method. Instead, for this method, we need to use the inverse to work this out. Just like we were doing earlier, we were saying timesing by 1/3 is the same as dividing by 3. Well, this time I'm dividing by 3. Dividing by 3 is the same as timesing by 1/3. So this question is the same as saying 7/9 times 1/3. When I get to this point, I know how to multiply fractions. 7 times 1 is 7. 9 times 3 is 27. Can I simplify it? No, so that's my answer. Let's try this with another question. So, first things first, can I divide the numerator by 3? 5 divided by 3? No, I can't. So I can't just divide it nice and easily. I'm going to have to turn this into the inverse and use multiplication. Now, again, there's 2 different ways of doing this. You can think about, I know that dividing by 3 is the same as timesing by 1/3. You might have heard this at school, is keep, change, flip. So keep in your head that you know that dividing by 3 is the same as timesing by 1/3. Keep that in your heads and watch what I do now. I'm going to keep, I'm going to change, and I'm going to flip what I know is 3/1 because that's the same as 3 wholes to 1/3. What did I say earlier? I said that dividing by 3 was the same as timesing by a third, and that's why the keep, change, flip works, because it is saying the inverse. It's the opposite of timesing by 3 is timesing by a third. If I wanted a third of something, I would split it into 3 pieces. When I've got it into multiplication, I multiply it nice and easy. 5 times 1 is 5, 6 times 3 is 18. Let's have a go at this one. So first things first, can I divide the numerator by 2? Yes, I can. So I could do 4 divided by 2 is 2. My noun is 8, so it's 2 eighths, which I can then simplify to 1 quarter, because I can divide them both by 2. Now, to prove this works using the keep, change, flip method, what you could do, dividing by 2 is the same as timesing by a half, and I can show that by doing keep, change, flip. 4 times 1 is 4, 8 times 2 is 16. If I divided them by 2 and simplified them, I'd get 2 eighths. And if I divided them by 2 and simplified them again, I'd get 1 quarter. So these methods get the same answer, but this method was a lot quicker than doing this method. But this will only work if you can divide the numerator by this number here. Okay, 2 final questions for you to have a go at. Pause the video and then we'll go through the answers. So, the first one, 3/5 divided by 2. Can I divide the numerator by 2? No, I can't, and get a whole number. No, I can't. So I'm going to do keep, change, flip. Or I know that dividing by 2 is the same as timesing by a half. So it's going to be 3/5 times a half. So 3 times 1 is 3. 5 times 2 is 10. Can I simplify it? No. So that's my answer. Next one. 4/5 divided by 4. Can I divide the numerator by 4? Yes, I can. 4 divided by 4 is 1. So this answer is 1/5. If I wanted to prove this by doing the other method, I know that dividing by 4 is the same as timesing by a quarter, or keep, change, flip. Multiply it would be 4 over 20. And if I divide these both by 4, it would be 1/5, which would give me the same answer. Well done for today. That was an awful lot of maths and a lot of revising. So well done. You've worked really hard. So hopefully you can now see the relationship between multiplying and dividing fractions. And you know there's different methods and little tricks that we can use to work out a question quicker. So, I now want you to have a go at Hegarty Maths 68 and 70, because there's one on multiplying fractions and one on dividing fractions. See you later.